Hello people, it's TJ and welcome to Science Simplified. In this lesson, I'll be teaching easy tricks for knowing the pH of solutions without calculating. Okay, now let's get to it. Since hydrogen ion concentration is represented mainly in standard form, I'm going to simply use an expression A times 10 raised to the power minus n to explain. Now this simply means then that 8 times 10 raised to the power minus n is the hydrogen ion concentration of the solution. Hydrogen ion concentration should be represented in standard form under normal circumstances. Then if so, we can easily deduce the actual pH or a value near it. The first part of this trick will be found very useful for OBJ exams. It allows you to easily and quickly deduce the range within which the pH of a solution lies. So from the representation, if A equals 1, then the pH will be equals to n, which is the power. Let's take an example for easy understanding. For this example, if the hydrogen ion concentration of a solution is 1 times 10 raised to the power minus 4, what is the pH? We can see in this question that A equals to 1 and n equals to 4. Now since A equals to 1, then n equals to the pH, which is the power, and the power here is 4. So this then means that the pH is equals to 4. The second part of this trick can be found very useful for OBJ tests. It allows you to quickly deduce the range within which the pH of the solution lies. For conditions when it is to be used, it can only be used when A is not equals to 1. That is, when A is greater than 1 but less than 10. Now in this case, the pH will be a value between n, which is the power, and n minus 1, which is the power minus 1. Let's take an example for easy understanding. For this example, what is the pH of a solution with hydrogen ion concentration of 1.69 times 10 raised to the power minus 6? Now we remember our expression A times 10 raised to the power minus n, and we can see here that our A is represented by 1.69. So since A is greater than 1 but less than 10, it simply means that our pH will be a value between n, which is 6, that is the power, and n minus 1, that is 6 minus 1, which is equals to 5. So this simply means that our pH is between 5 and 6. So for emphasis sake, I would love us to use this method to deduce the answer of this question. This question was asked by JAM in the year 2000. So let's try it. The question states the pOH solution of 0.25 mole per dm cube hydrochloric acid is. Now looking at the options: A 12.40, B 13.40, C 14.40, and D 14.60. Now in this question we are given we are asked to find rather the pOH. So we'll first need to deduce the pH before we can deduce the pOH. Now in order to make 0.25 mole per dm cube, which is our hydrogen ion concentration, look like our representation, we have to convert it to standard form. Now in standard form, this equals 2.5 times 10 raised to the power minus 1. Since A, which is 2.5 here, is greater than 1 but then less than 10, it simply means our pH pH will be between n, which is 1, and n minus 1, which is 1 minus 1, which equals 0. So the pH is between 0 and 1. Now, since we've deduced the pH, we can then move forward to deduce the pOH. We remember that from general chemistry, pH plus pOH equals to 14. This then means making pOH subject of the formula pOH equals 14 minus pH. Now, pOH equals 14 minus 0, which is the first value, equals 14, and pOH also equals 14 minus 1, which is the second value, is equals 13. This will then simply mean that the pOH will lie between 13 and 14. Now, looking at the options, we can see that the only value that lies between 13 and 14 is option B, 13.40. So this simply means our answer is B. For the last part of this pH trick, we simply need to know the logarithm of numbers 1 to 10. Remember that the formula to find pH is equals to minus log of the hydrogen ion concentration. For easy understanding, we'll quickly take one example. Now pull up the logarithm of 1 to 10. Do not feel lazy to learn this. It's a very fast trick. In this question, find the pH of a solution with hydrogen ion concentration of 5 times 10 raised to the power of minus 9. Now we simply put our H plus into the bracket. So we have pH equals to minus log into the bracket 5 times 10 raised to the power minus 9 close bracket. Now we then simply use log to multiply figures inside the bracket. We're simply going to have minus log 5 minus, which comes from the minus 9, and minus, which comes from the log. So we're going to have minus 9 log 10. So breaking this down, we have minus log 5. We know that minus 9 minus is going to equals plus. So plus 9 log 10. Now arranging this in a more appropriate manner, we're going to have 9 log 10 minus log 5. Now looking at our representation on the left hand side, we have that log 10 equals 1. So it's going to be 9 times 1 minus, or again looking at our representation, we have that log 5 equals 0.7. So this is going to equals 9 minus 0.7, and this equals 8.3. So this then simply means that our pH is equals 8.3. Okay, now for a quick reminder, remember our expression A times 10 raised to the power minus 9. Now since A is greater than 1 but less than 10, this means that our pH is between N, which is 9, and N minus 1, which is 9 minus 1, equals to 8. So this then means that our pH is between 8 and 9. Now if you look back at the answer we got, you can see that our answer is 8.3, and this is between 8 and 9. Yeah, so that's all for now. Thanks for watching. Don't forget to click the like button. And if you want to get more tips and tricks like this, just click the subscribe button. Thanks again, and bye for now.